Ever wondered why some apps feel like they are reading your mind while others make you stare at a spinning circle? That difference is usually just one thing: caching. In the world of software engineering, speed isn't just a luxury, it is a requirement. If your app takes more than a second to load, users start to leave. To fix this, we use a layer of high-speed storage called a cache. It's the secret sauce behind every major platform like Netflix, Instagram, or Google. Today, we are going to peel back the curtain and look at how caching works, why it is so much faster than a traditional database, and how it transforms the user experience from sluggish to instantaneous. We will explore memory hierarchies, the trade-offs of data consistency, and why the fastest request is the one you never have to make to the server at all. Let's dive into the world of high-performance systems. To understand the solution, we first need to understand the bottleneck. When you request data from an app, that request usually travels across the internet to a server. That server then talks to a database. Databases are great for storing millions of records permanently, but they are relatively slow. They usually store data on a hard drive or an SSD. Accessing a disk is like driving to a library to find a book. It takes time. Then the data has to travel all the way back to your phone. This round trip creates latency. If every single user asks the database for the same profile picture or the same trending post, the database gets overwhelmed, and the library gets a massive line out the door. This is where the system starts to crawl, and your users start to get frustrated with the lag. Imagine you are cooking a meal. You need salt. You could walk to the grocery store every time you need a pinch, but that would be ridiculous. Instead, you keep a small amount of salt in a shaker right on your counter. The grocery store is your database. It has everything, but it is far away. The salt shaker is your cache. It is small, it does not hold everything in the store, but it is right there when you need it. In computing, we do the exact same thing. We take the most frequently accessed data from the slow, giant database and put it into a small, super fast piece of memory called RAM. Accessing RAM is thousands of times faster than accessing a disk. By keeping the salt on the counter, your cooking or your app becomes incredibly fast because you have eliminated the travel time.
So how does a cache actually store this data? Most caches, like Redis or Memcached, use a simple system called key-value pairs. Think of it like a dictionary or a locker room. You have a unique key, like a user ID, and a value, like the user profile data. When the app needs data, it first asks the cache, "Hey, do you have the data for key 123? If the cache says yes, that is a cache hit, and the data is returned instantly. If the cache says no, that is a cache miss, and we have to go back to the slow database to fetch it. Once we get it from the database, we usually save a copy in the cache so that the next time someone asks for key 123, it is ready to go. This simple logic saves millions of database queries every single day."
Now, you might be thinking, why not just cache everything? Well, there are two main problems. First, RAM is expensive. You cannot store a petabyte of data in a cache. Second, there is the problem of stale data. Imagine you change your profile picture. The database updates immediately, but the cache still has your old photo. If the app keeps showing the old photo, the user gets confused. This leads us to one of the hardest problems in computer science: cache invalidation. We have to decide when to delete or update the cached data. We might use a time to live, or TTL, which tells the cache to throw away the data after 10 minutes. Or we might manually purge the cache whenever the database changes. Balancing speed with accuracy is the ultimate challenge for developers.
Caching does not just happen on the server, it happens everywhere. Your web browser caches images, scripts, and style sheets, so it does not have to download them every time you refresh the page. This is why a website feels much faster the second time you visit it. Then there are content delivery networks, or CDNs. These are caches located all over the world. If you are in Tokyo and you want to watch a video hosted in New York, a CDN will store a copy of that video in a Tokyo data center. Instead of the data traveling across the Pacific Ocean, it only travels a few miles to your house. By bringing the data closer to the edge, we reduce latency to almost nothing, making the global internet feel like a local network. To wrap up,
Caching is the art of trade-offs. You trade memory for speed and complexity for performance. When you use an app that feels buttery smooth, you are witnessing the result of layers upon layers of caching working in harmony. From the CPU cache inside your phone's processor, to the browser cache, to the CDN, and finally the server-side Redis cache. Understanding caching is essential for any developer who wants to build scalable systems. It's not just about making things fast, it's about making them efficient and reliable under heavy load. Next time you see a loading spinner, you will know exactly what is missing: a well-implemented cache. Thanks for watching, and hopefully your next project will be faster than ever.